to check with my supplies. It is make a generator, but I don't know if that's what we're doing or not. And by the way, I did post the video of the car, so I hope you watch it and you enjoy it. And right now, I'm gonna be starting the reading for Learn About Magnets and Electricity. Sorry. Okay, find out why some subatomic substances are magnets, what electricity is, how electricity and magnetism are related, vocabulary, magnet, electricity, electric energy, circuit, and electromagnet. Magnetism. If you took apart all the appliances in your home, you'll find that many of them include the stereo, the blender, the vacuum cleaner, and even the doorbell contain magnets. In fact, all electric devices that have motors or loudspeakers use magnets. You probably know some of the properties of magnets. They can attract or exert a magnetic force that pulls over magnets toward them. They can also repel or exert a force that pushes other magnets away from them. The present theory of magnetism is that it results from the motion of electrons, the particles outside the nucleus of an atom. The spinning of an electron produces a tiny magnetic field. In a region which there is magnetic force. In most substances, electrons occur in pairs and spin opposite directions, canceling out each other's magnetic fields. Substances such as iron, cobalt, and nickel, however, have electrons that are not paired as a result. As a result, their atoms do not have magnetic fields. These atoms cluster together in microscopic groups called domains. A domain contains billions. The atoms cluster together in microscopic. A domain, billions of atoms with their magnetic fields aligned, all contributing to the magnetic field of the domain. In a magnet, all the domains of a substance are aligned in the same direction. The magnet fields all work together in an object that is not a magnet. The domains point in different directions and cancel each other out. However, when a magnet is brought close, the domains in the objects sometimes can align themselves. Then the object itself becomes a magnet. When the magnet is removed, the domains return to their random arrangement, and the object is no longer a magnet. The magnetic field produced by a magnet acts only on certain magnetic materials. And by the way, a magnetic material is like a metal, like when you're alright, let me think. For example, what's made of metal? Name something that can be made of metal. I don't know. Okay, got it. See this charger I have? It's a charger for an iPhone or an iPod Touch, whatever like one of those kind of devices. See this part, where the silver part right up here is metal. So if I put let me see if I got anything that's metal. One second. So, I'm looking, guys. I'm looking. Okay. Metal can be like something that it tracks or something. Like metal can be really strong, and metal, like I was saying, is really important. I don't think I have anything to see. Yeah, I don't got. Alright, at the moment I don't have anything out that is made of metal. I'm sorry. So I'm just gonna keep reading. But metal is anything that has a north and a south pole. And a north and a north can attract, and a south and a south can't attract. But a north and a south can, and a south and a north can. Like north and south, south and north, north and south. They can all attract. And then if you actually a compass always points north because that's the way direction you're going in. So if I turned, it would be northwest. See, that's why if you have a compass like on here, it's in the book. I don't really have one with me, but if I did, I would show you it. If you look right there, it shows north. I'm trying to bring it into you guys. See, that would help. See, it talks about a compass and what it is and shows you. So a compass is pretty much just to guide you. Okay. Sorry, let me just get that back on here. Alright. So anyway, I'm just going to keep reading. The magnetic field produced by a magnet acts only on certain magnetic materials. It passes through other materials such as wood products or water. That is why you can use a magnet to move a pin or a tack placed on the other side of a sheet or paper. The pin or tack becomes a magnet itself when the magnetic field causes two magnets to align. The strength of a magnetic field decreases as the distance from the magnet increases. The magnetic field is strongest at the poles of the magnet. Every magnet has two poles. The poles are identified as north and south. The poles of a bar magnet are opposite sides of the bar. This is what we just talked about. If the magnet is free to move, its north pole will point north, and south pole will point south. This is how a compass works. Even if a magnet is broken in half, the halves will each have a north and a south pole. In fact, each domain of a magnet has two poles. If you picture the aligned domains of the magnet, you can visualize how each half will still have north and south poles. In the same way that electric charges attract or repel each other without touching, so do the poles of the magnets. The north pole of one magnet is attracted to the south pole of another. Two north poles or two south poles repel each other. So unlike poles attract and like poles repel. Page 86. We're flipping to. Well, if you don't have a book, then just keep listening. Electric circuits. Reluctants have a negative charge. This charge is responsible for electricity. The interaction of electric charges. If you ever have wrapped a balloon and watched it stick to a wall, you have seen the effect of static electricity. In static electricity, the changes that can represent don't flow from one place to another. Static electricity is this. Before I go on, I just want to give you guys a little what's that? Okay, we all have seen a balloon probably in our life once, twice, probably a lot of times. So, alright. So if I took a balloon and I rubbed it against like the wall or the TV, remember how like it sticks there? Well, if I rub it against my hair's gonna get all frizzy, like it's gonna be all over the place, like this and like this. It's gonna get really big, and also the balloon's gonna have static electricity in it. But when it falls off, the static electricity is decreased and it's gone. Okay, so I'll keep reading. Current electricity is the flow of electric charge. This is electricity that runs appliances such as flashlights, washing machines, and televisions. Current electricity is the movement of energy from one place to another. It also is called electric energy. Electric energy can be converted to another form of energy, such as heat, warm, light, like this light shining on me, or motion means moving. Unlike magnetism, electricity requires something to travel through. The materials must be electric conductor. Most materials that are good conductors of heat are also good conductors of electricity. Copper is one of the best conductors because it also has malleability and ductility. It is also used for electrical wires. For example, if I were to take this apart, which I would not do because I'd be very mad at myself, I would see that in there, and it says ductility because it can bend. It can bend. It also has potential energy. Remember we were talking about potential energy yesterday? I have the potential energy to bend this. Okay, I'll just keep going. In order for a current to I have to. Alright, I'm gonna just continue on the next video. Okay, I'm gonna just continue this. on part 2. So, Crunchy 101 signing off for now.